Hello, my name is Scott Mittl. I'm the Vice President of Sales at Insaco Incorporated. I wanted to talk today about coefficient of thermal expansion with regards to Sapphire. Sapphire exhibits a property called anisotropy. It's a very confusing property, and I want to try to describe it here in a show and tell environment with a couple of different Sapphire tubes in the bowl. The first thing I need to describe is what is sapphire. It's a very common misconception of what it is. Sapphire can be mined. However, we only work in the crystal-grown, synthetically grown materials. Those materials typically are water white. They would be very clear. If you would look at a mined product at a jewelry store, that would typically be blue or have some sort of a hue to it. That hue is due to impurities. We are typically using material which is a very low impurity material. Sapphire is the single crystal version of aluminum oxide. So aluminum oxide, the polycrystalline version, most people are accustomed to. In the instance of this polycrystalline version, this is 99.5% aluminum oxide, and it can be machined, ground, and polished to very good surface roughnesses, probably down to 4 microinches or so. In the case of sapphire, sapphire is the single crystal version of aluminum oxide. So here's an example of a sapphire tube that was manufactured here at Insaco. If we would say that this is a 0-degree sapphire tube, the C-axis, which would be coming out of this face, would be parallel to the rotational axis of the tube itself. This is very critical when you're manufacturing sapphire tubes for infrared countermeasures or for high temperature applications, because you would want this tube to expand and contract uniformly. If it does not expand and contract uniformly, whatever you have attached to it is going to break and leak, because the material that you attach to it wants to be what's called isotropic, meaning it will want to expand and contract as a circle as opposed to as an elongated rod or tube. So we typically have manufactured here at Insaco either R-plane tubes or C-plane tubes, preferably C-plane tubes. I've also provided an understanding of the bowl. So this is a very small bowl. This was grown by Coropolis. This is 20 plus years old, but it's a great example from a show and tell perspective with regards to orientation. So here is a tube that could have come out of this bowl. And this is the C-axis. So the orientation of this bowl would be called an A-plane bowl. So the A-plane would be coming up out through the bowl, and the C-axis is the way we would be core drilling the piece. So again, here is an example, and let me just put this together. So what we're doing is we're doing this. So that is now a C-axis tube. Again, anisotropy is probably the most critical feature of sapphire that is most misunderstood. In the instance of these materials, once you understand the anisotropic behavior of the material, for example, coefficient of thermal expansion is an easy one to show and to describe, but sapphire also exhibits a different dielectric constant. There are a lot of other material properties other than coefficient of thermal expansion which you need to pay attention to. But in the instance of coefficient of thermal expansion, it is the best one to use in the case of a show and tell environment. So again, sapphire is an anisotropic crystal. If you pay attention to that C-axis, your life will be much easier with regards to designing with these materials. So the next time you need some information on sapphire, you need to understand how to machine a product or how a application and the material properties will benefit you, please consider Insaco, and please go to www.insaco.com. Thank you.